Hey folks, today we're talking about trig. So this goes back to our pre-calc days, reviewing some of those topics that we did in the second semester right away of pre-calculus. So you've got your unit circle. This year you don't get to use the unit circle on anything, so you have to be able to build your unit circle on your own. Couple things to remember. This is depending on what teacher you have. Some teachers teach the unit circle like I do. Some teachers teach it as coordinates. I just want to show you what they're talking about here. So if I drew a pi over 3 triangle, right angle, my reference angle is a 60. That means this side length is square root 3 over 2, and this side length is 1/2. Now, if I look at this point right here, how far did I go on the x-axis? 1/2. How far did I go on the y-axis? Square root 3 over 2. So that's why they designate these points. It's just another way to think of, I had you guys just draw the picture over and over and over again, and I like that way better because I think it shows you understand how the unit circle works. But that's what they're talking about when they talk about the coordinate pair. Remember that x is the same as cosine, y, I messed it up already. Y is the same as sine. And then tangent is equal to sine over cosine, or y over x. So hopefully that brings back a ton of memories from your good old pre-calculus days. So we've got some relationships. We've got the big three are sine, cosine, and tangent. And then we have their reciprocal functions, secant, cosecant, and cotangent. They're the reciprocals of the regular functions. Now this can go both ways, though. Keep in mind that if secant is the reciprocal of cosine, then cosine is the reciprocal of secant. Sine is the reciprocal of cosecant. And then there's two ways to think about these. I usually only think about them in terms of sines and cosines too. But I guess you could write this up as tangent is the same as 1 over cotangent. And then cotangent is the reciprocal of tangent. So what is a trig function? So last year you knew how to do it. Maybe you didn't really understand what it was. Trig function is very simple. It's just the unitless ratio of two of the three sides of a triangle. Unitless ratio, two of the three sides of a right triangle whose reference angle this is the reference angle. Now, that's not necessarily the same angle as theta. You got to be careful here. The reference angle, I shouldn't have highlighted theta. I should have highlighted this. That's the reference angle. Theta is not the reference angle. Theta is the angle, because what I mean by that, like theta could be, let's say, 2 pi over 3. So theta would be the angle all the way over here. I wish I could highlight that in a different color now. Yuck. Anyway, theta is the angle that takes you over here, 2 pi over 3. The reference angle would be the 60. So let's draw that actually. Let's do a different one. Let's do 7 pi over 6. Theta is equal to 7 pi over 6. But my reference angle is only 30 degrees. So the reference angle is the angle that we use. Now I know that this is 30 degrees. This is going to be negative 1/2. This is going to be negative square root 3 over 2. And then we can apply our trig functions from there. If your radius is anything other than 1, when you're in the unit circle, the radius is always 1. When you're outside the unit circle, we just multiply these values by whatever the radius is. So if this is has a radius of 7, I would do 7 times negative 1/2 and then 7 times negative square root 3 over 2 to figure out those side lengths. All right, so let's have you pause here, go back in the old time machine and see if you can do these 6 trig functions. If you need your unit circle, okay, I get it, but you're going to want to get away from that. What I mean by that is you're going to want to get to a spot where you can just draw these in your either on the paper or you could see it in your head. So pause, try to do at least one at a time, and then pause and then go, and then pause and then go. All right, so I'm going to do this one the long way, 5 pi over 3, so I would draw a little unit circle. 5 pi over 3, I'm counting by 60s. Counting off 5 60s, so that's 1, 2, 3, 4, 5. That means my triangle looks like this. Right angle, my reference angle is what I counted by, 60. Then I fill in the sides. Opposite of 60 is negative square root 3 over 2 because it's pointed down. And then positive 1/2 because it's pointed forward. And since this is sine is the same as the y value or the y side. So this would be negative square root 3 over 2. Like I said, I would encourage you to pause here and try it on your own next. So let's see how you did. I'm going to make another sketch. 5 pi over 6, I'm counting by 30s. Oh, just a quick reminder, how do I know that's a 30? Pi is the same as 180. Pi and 180 are equal to each other. So if I'm taking pi divided by 6, that's essentially saying it's 180 divided by 6. 180 divided by 6 is 30. 1, 2, 3, 4, 5. So my triangle is over there. Right angle, reference angle this time, I don't know if I can squeeze it in there. 30 degrees, which means this is 1/2. This is negative square root 3 over 2. Cosine is the x value, so this is also negative square root 3 over 2. Tangent of 7 pi over 4. Hopefully you've paused already and given this a try. Pi over 4 is the same as 45s. 1, 2, 3, 4, 5, 6, 7. Take that triangle and blow it up. Right angle, my reference angle this time is a 45 degrees. So that's negative square root 2 over 2, positive square root 2 over 2. And then tangent, you got to be a little bit careful, but tangent is y over x, sine over cosine, opposite over adjacent. All three of those things will get me to a spot where I have negative root 2 over 2 over positive root 2 over 2. Nobody in the world can divide fractions, so what we do instead is flip and multiply. So the 2's cancel, the root 2's cancel, and I'm left with negative 1. Cotangent of 3 pi over 2, I'm counting by 90s. So I would count 3 90s. 1, 2, 3. I call these corner points. I know it doesn't really make sense to call them corner points because you're in a circle, but that's what I call them. These are not triangles. These are points. This is the point 0. I would go nowhere on the x, and I'd drop right down on the y. Now, what do you know about cotangent? It's the reciprocal of tangent. Well, what do you know about tangent? Tangent is y over x. So cotangent must be x over y. So for us, that would be x is 0, y is negative 1. 0 divided by negative 1 is 0. Secant of 3 pi over 4. What am I counting by? I'm counting by 45s. I guess I'll go up here. 1, 2, 3. Take it, blow it up. Right angle, 45 degrees. Root 2 over 2. Negative root 2 over 2. Then I'm going to do secant, which is the reciprocal of cosine. So I'm going to take the cosine and reciprocal it. So my cosine reciprocaled would be negative 2 over root 2. This is bad news because you have a root on the bottom. No go, no good. So I multiply by, we call this rationalizing. So negative 2 times root 2 is negative 2 root 2 over Root 2 times root 2 is just 2. I mean, root 2 times root 2 is really root 4, but the root of 4 is just 2. Those 2's cancel, and I'm left with negative root 2. And let's see how you did on the last one. Last but not least, cosecant of pi. So I'm going to just sketch pi. Pi is over here. That's not a triangle. That's a point. That's the point negative 1, 0. Cosecant is the reciprocal of sine. So sine is 0. 0 into a fraction. And then when I reciprocal it, I get 1 over 0, which we all know is undefined. So there's a crash course on what we spent a ton of pre-calculus going over. So hopefully that was just stuff that you just needed a little refresher or a reminder on. If you couldn't do that stuff, you and I should probably meet after school and try to review some of those big ideas. Oh, this is just saying, let's see how we did. Yep. Then what? 0, negative root 2, and DNE. They say DNE. I guess you could say DNE or undefined. I prefer undefined. You should rememorize the unit circle. Yes, that is true if you have not already done this. If you cannot do that in your head, you want to get to a spot where you can begin to do that stuff in your head. All right, find all remaining 5 trig values. So who are the other 5 trig values? So they gave us sine. So here I am annotating my stuff, writing myself a little reminder on what they're asking for. The 5 trig values, so we've got sine, but cosine, tangent, and then they're reciprocal. So that would be cosecant, secant, and cotangent. If sine of theta equals negative, so I'm going to make a chart right now. I need sine of theta, cosine of theta, tangent of theta, and then cosecant of theta, secant of theta, and cotangent of theta. All right, so one of these we already know. They told us that sine is negative 3/4, which means that, well, I guess I could go do cosecant right now if I wanted to, but I'm not going to. So what do we know? The other hint they gave us was that sine is negative 3/4, and cotangent of theta is greater than 0. So we want to find the angle such that the angle falls between 0 and 2 pi. So let's kind of make a sketch of what we got going on here. If you remember, we did this in pre-calc where we would do little check mark things. So what do you know about sine? Sine is negative. Sine is negative in quadrants 3 and 4. Cotangent, which is y over x, or x over y, I'm sorry, is greater than 0. So if you're going to be positive, when you divide x and y and you end up being positive, they need to be the same sign. So that's going to be in this quadrant where x and y are both positive, and then down here in this quadrant where x and y are both negatives. Now I have an idea of what my triangle looks like, and I can make a sketch of that triangle. So I'm going to have a quadrant 3 triangle. Right angle, and for now we can only call this angle theta. So I should be able to fill in 2 sides. I know that sine is opposite over hypotenuse. So I can fill in those 2 sides. Opposite would be 3. Hypotenuse would be 4. Then where do I stick the negative? You must put it, I should say. You can never have a hypotenuse that is negative. It's just on an angle. So you're going to attach it to the 3. All right, now if I'm going to use this thing to figure out the rest of these trig functions, I need to know what this side length is. And we can find that out by doing our good friend, the Pythagorean theorem. So I'm going to call this b squared. So I'm going to have negative 3 squared plus b squared equals 4 squared. So that's 9. That's 16. Subtract 9, you would get 7. Square root, you would get b equals plus or minus the square root of 7. And you want to include that plus or minus because you're going to have to pick Is it positive or is it negative? And in this case, because this goes backwards, I know that this is negative square root of 7. Okay, now we have all the sides. We can start to fill in the details. Cosine then is x over, because this hypotenuse is not 1, you're not in the unit circle, which means you need to do SOHCAHTOA. So I'm doing adjacent over hypotenuse, which is negative square root 7 over 4. And then I'm going to do tangent, which is opposite over adjacent. And this one is where things start to get interesting. I'm going to do negative 3 over negative root 7. So first of all, the negatives are going to cancel out, and then I need to rationalize this. So I get 3 root 7 over 7. You try to find the other 3. They're just take these and make their reciprocals. All right, if you haven't paused yet, you should get in that habit. Anyway, let's see how you did. So reciprocal of this, the negative always is on the top, so I reciprocal there. Now, when I reciprocal this, I'm going to have a root on the bottom, which then I have to rationalize. And I think by the end of last year, you guys were pretty good at rationalizing in your head. And then this one, I actually don't reciprocal this, because this is when it's already been rationalized. I go back to before I rationalize it, and I reciprocal that. It actually makes your life a lot easier. Okay, so there's our first spot. We found all 6 trig functions. Then find theta such that, now I don't know how he has you do this without using your calculator at this point. I would use my calculator here. Because what I would have to do to find theta is I'd have to kill off sine, which means I'd have to do sine inverse. So theta is equal to sine inverse of negative 3/4. Now this is where things start to really get complicated. Check your mode, make sure you're in radians, and then we're going to go to degrees. We'll go back and forth because the radian answer is what we need to be in, because all this stuff is referencing 2 pi, which means you have to be in radians. So degree answers will not work here. But radians usually don't make as much sense as degrees, so we're going to kind of bounce back and forth. So I'm going to go to radians first. I'm going to do sine inverse of negative 3/4. So we get that theta is equal to negative 0.848. And now I'm going to change my mode to degrees to kind of figure out where that is actually. Second enter, bring it up again. So this is equal to negative 48.590 degrees. So now I have a better idea of where this angle is. Okay, so let's try to figure out now what's going on here. Where is this? Is this theta? Not quite. Not quite. I shouldn't have written that because this is a little bit untrue. Look at where our actual triangle is. Our triangle is in quadrant 3. Where is negative 48 degrees? Negative 48 degrees is in quadrant 4. That's because our calculator, if you remember when we did inverse, where inverse lives, sine inverse only lives in these 2 quadrants. I don't know if you remember us drawing that little arc thing, but that's what that's referring to. So we're going to have to do a little bit of detective work. But we did figure something out. If this is the angle here, this is the 48 point blah, blah, blah. Well, the triangle we're looking for, I'm going to go back to orange here. The triangle we're looking for is over here, but it's the congruent triangle just reflected. So we now know what the reference angle is. So my reference angle is this 0.848. That's in radians, which is, I'm going to put in parentheses, 48.590 degrees. Now that's this angle. Now why is it negative on our calculator? Because it had to drop us down here into this quadrant 4, but the angle itself is still 48 degrees. So what is theta then? The question isn't what's the reference angle, that's one of them. But what is the reference angle? What is theta? Well, how would you get theta if theta would be then this all the way around to there? Think about it. Try it on your own. See if you can figure out, pause here, see if you can figure out what theta is. All right, well, how far is it from here to there? In radians, it's pi. So I would take this number up here. So I'm going to go back to my other mode. That brings up my negative blah, blah, blah. Now I need to make it a positive, so I'm going to times it by -1. And then I'm going to add a pi to that. That's going to take me to the angle 3.989. Which would be how many degrees? So 48.59 plus 360 degrees would be 408. No, not 360, darn it. I wanted to do plus 180, didn't I? 228.59, which is 228.590. 228.590 degrees. And then what's the other angle that would give us the same sine value as theta? So there's two ways we could write. No, I can't, darn it. I was going to say two ways. We could use the negative, but we can't because it's got to lie between 0 and 2 pi. So you can't have any negative answers. So if negative 8.48 takes me here, but I want to go around to the positive, what would I do to that value? This is crazy. I love AP Calc. I could, if I wanted to go all the way around back to there, this is what they're calling beta. Beta would be equal to negative 0.848 plus 2 pi. Negative 8.8 takes me down to there, and if I add 2 pi to that, it would take me around to where I am. So I like to have the actual. I should have stored it. Why didn't I store that? Darn it. Okay, so I'm going to times this. I guess I could just do plus 2 pi at this point. So beta is equal to 5.435. Whoo! That is a doozy. I'm going to pause here for a sec. Okay, where were we? So here we are trying to solve some trig equations. So for 0 is less than or equal to theta is less than 2 pi. This is just basically saying the unit circle. And I might say like one lap around the unit circle. This is what you are, that's supposed to be an A. One lap around the unit circle. So this goes back to what we did in pre-calc. You would just solve it and figure out where the triangle exists in the unit circle. This is a little bit different. This is for all real numbers. This is the unit circle, but with infinite laps forward and backwards. And that might sound intimidating, but it's actually, it's kind of nice. It's not that overwhelming to figure out how to write it up. Okay, so our equation is sine of theta equals negative square root 2 over 2. So let's figure out where that lives first. So sine is negative down here and down here. Check and check. Sine is square root 2 over 2. So what triangle could I draw that would have a sine value of negative root 2 over 2 and negative root 2 over 2. Hopefully you figured out that we were counting by 45s. So the 45s that would be in there or in these quadrants. So the answer to part A, let's see, 1 pi over 4, 2, 3, 4, 5 pi over 4, or 5, 6, 7 pi over 4. So that's the solution when we're only talking about one lap. Now, if we go infinite laps, let's see what that would look like. So we would go 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and around like that. But we'd also have to go back and back and back. Think about it this way, though. How far, if I went here to 5 pi over 4, how far would it take me to get all the way right back to 5 pi over 4? Well, hopefully you thought that it would take me 2 pi to get around there. And that's exactly what we're going to do. We're going to take our solution, and then we're going to add 2 pi. So that would look something like, so for part B, I would take my 5 pi over 4, and I would add 2 pi. Now, that would just take me one lap around. I want to go around infinitely many times, but I also want to go backwards one lap infinitely many times. So I'm going to take 2 pi, and I'm going to multiply it by n, where n is an element of the integers. So remember what the integers are. That's the set ... -2, -1, 0, 1, 2, ... So think about it. If I put a 0 here, that would just take me to 5 pi over 4. If I put a 1, it would take me one lap forward from 5 pi over 4. Then if I put a 2 in there, that would be 4 pi's, which would take me another lap, and another lap, and another lap, so on and so on and so on. So this is how we write up our solution set when it's more than just one term. Or one lap around. I said one term. I meant one lap around the unit circle. And then this one should feel pretty familiar. We did a homework problem like this. This was on, I think, P2. So what I'm going to do is I'm going to use this to design a triangle. So I know that arc sine is t squared, which means sine of whatever the angle is t squared over 1. That's what that's telling me. Arc sine finds angles. So if I think about this from a different perspective, I did arc sine is really sine on the other side. So if I were to write this out, it would look like this. Maybe this is confusing. Let me try this. Arc sine of t squared is equal to some angle. Well, if I take sine of both sides, this is going to be, I can make that into a fraction. And if I do sine of both sides, I've killed this off and I put the sine on the other side. This is much easier to organize, though, because now I can do SOHCAHTOA, and I have opposite and I have hypotenuse. So if I go to my picture, they didn't give me enough detail, so I don't have to orient my triangle in any way. This is a right angle. I'm going to call this theta. My opposite side would be t squared. My hypotenuse would be 1. Then I can use this triangle now to try to answer this question. I need tangent. So if I want to do tangent of this triangle, I need opposite over adjacent, which means I need to find this side. But we can find that side fairly quickly using the Pythagorean theorem. So that for us, that would look like a squared. So t squared plus b squared is equal to 1 squared. T squared squared is t to the 4th plus b squared equals 1. Then I'm going to bump the t to the 4th to the other side. So I would get b squared equals 1 minus t to the 4th. And then I would square root, and I would get b is equal to plus or minus the square root of 1 minus t to the 4th. Now, like I said, we don't have a designation where this is in the unit circle, so I could use either one of those. I'm going to choose to do the positive. And then I can finally take all of this and evaluate the tangent of arc sine of t squared. Tangent is opposite over adjacent, so that would be t squared over 1 minus t to the fourth, getting square rooted. And if this is a free response, you would stop here, don't clean it up. If it was a multiple choice, they would rationalize this, so they'd get the root off the bottom. So they'd multiply the top by t squared 1 minus t to the fourth over 1 minus t to the fourth. Either one of those would be acceptable solutions, depending on which form you're looking for. Okay, we don't have any more examples, just a couple of things to highlight. These are worth memorizing. This one you should already know. Cosine, these are called the Pythagorean identities. He calls them the PIDs. Papa PID, the main one, is cosine squared plus sine squared equals 1. Then we have 1 plus tangent squared equals secant squared. We find that by taking this equation and dividing it by cosine. And then we have this. We find this by taking this equation and dividing it by sine. And then remember that there's all different variations of these. You can manipulate these. Like, for instance, he took the tangent squared and moved it to the other side. So it was secant squared minus tangent squared. So I can manipulate that. I can move those around. And, boy, these are ones that I don't know how often you're going to really need them. This is the double angle. We didn't even cover this one last year. I mean, technically we did. We didn't cover it as something that you had to memorize. This one we didn't cover for sure. So these are things that I would put on the probably worth memorizing pile. If you're somebody taking the AP test, they're probably worth memorizing, but I don't think they're going to be the difference between you getting a 3 or a 4. It might be the difference between you getting a 4 or a 5, but I don't think they'll be the difference between you getting a 3 or a 4. All right, so that's it for our intro unit. Next up is the calculus. Good luck.